Okay, today's lesson is about absolute value equations, and there's two other kinds of equations that are solved kind of the same way. We have one big worksheet on this that I'm going to give you today. It's really big, but it's a worksheet that has two sides to it, and it's got all these kinds of equations. So there's not, you don't have to like fight through word problems or whatever. It's just knowing how to solve these. Now there's a couple things to watch out for on these kinds of problems. This one, it's kind of a tough one from your homework. Problem number 45, it said, it had a graph of this thing. You remember how this worked? It said, here's a graph, and it had like two things intersecting. And here's another graph, which just had a normal parabola. Okay, well on the one, they had graphed this and graphed this and saw where they crossed. It was like this. Don't forget, that's a great strategy for solving this kind of an equation. If you've got any equation, if you graph the left, you graph the right, you see where they cross. Where did we get this one from? That's if you moved everything on this side over to the other side and set the equation equal to 0, then you could have a parabola and you'd just find the two zeros or the roots down there. Okay? So, what if it's not allowed to use a graph? If it's algebraic. So we've got two tests coming up. On Monday, there's one test, and on Tuesday, there's another test, back to back. And we haven't, you can think of them as quizzes, but everything in here is going to be like this. It's an assessment. Whether you want to call it tests or quizzes, they're all the same. They're all the same size, except for the final. That's obviously bigger to match the 2-hour period that you have for a final. But basically, they're like 9 questions long. They're kind of like just in between a quiz and a test. They're a little bit bigger than a quiz, but they're not usually as long as a normal test would be. But they're these Marzano-style deals. And these 9-question tests will be split into parts where, like, one of them is all graphing calculator stuff. You can use your graphing calculator, encouraged to use your graphing calculator, and that's a test on graphing. The other test is called algebraic manipulation. That's where you can't use the graphing calculator. You got to do it just with algebra. All right? So if I had to solve this thing with a graphing calculator, it'd be easy. I graph the left side, I graph the right side, I see where they cross. That'd be really easy with the graphing calculator. Okay, it's good to know that because on the SAT test, they let you use the graphing calculator all the time, anytime. Okay, so it's good to know that. But we also need you to know how to do algebra, which means in this kind of a problem, you have to know how to handle absolute values. That is the important part. All right. So your first step is to get that important part alone. Question? That's a good question. It depends on the problem. I'll give you an example. This one before, okay, the question for those of you at home was, which would be easier? Use the graphing calculator to type all that in and see where they cross, or to just do it with algebra? In this case, it's easy enough. I'd probably do it by hand. But this other one, that is a bear to do by hand. I showed last hour, and I'm going to actually show you at the end of the hour. It takes like 9, 10 steps. Okay, graphing calculator, it's type it in, find where they cross. And if you know how to do intersect on your calculator, like that second calculate intersect, way easier to graph. So it depends on the problem. All right, so on this one, if I'm doing it by hand, I have to get that green circled part alone. Think of it just like it was its own variable. If it was, then this equation would say 2a minus 4 equals 10. And I'd have to get the a alone, right? Well, it's just like that. Would you please write down this equation? And start by getting this part alone. You'll need a pencil. You'll need... Good. Write it down. Give it a shot. All right. So, did you start by adding 4 to both sides? 2, absolute value of x minus 3 equals 14. And then what did you do? Divide by 2. So you got absolute value of x minus 3 is equal to 14 divided by 2 is 7, right? Now you got to know how to fix these absolute values. I did hint at this the other day. I don't know if you remembered me or not, but absolute values always have two answers. Think about it. What's in here? Just ignore what's in here for a second. Just tell me, what does it have to equal? 7 or -7. Either way is going to work, right? So now I just use my magical back in time thing, and there's my problem. So x minus 3 has to either be 7 or x minus 3 has to be -7. And then I solve those two little equations. Go ahead and do that right now. And you'll have two things. X equals 10 and x equals, add 3, -4. Two answers. Now here's one thing that's really important that kids generally don't like to do, but when you only have 8 questions on your test, and if you miss one of them, you're guaranteed, no actually, if you miss just one of them, it won't hurt you at all. You'll still get a straight A. But typically, if you're like a normal kid, you've already made one dumb mistake, and now if you make another dumb mistake, you're going to go from an A to a B on the test, because there's only 8 questions. So if you lose a point, it makes a big difference. If you really care if you're right, you better double check these numbers and make sure they actually work. And it's really true. A lot of times you can tell whether you're right or not before you hand the thing in. Take a 10, stick it in. What's 10 minus 3? 7 times the 2. 14 minus the 4. 10. It worked. Will it always work? No, it won't. That's the point. In fact, sometimes you can even follow all the rules perfectly, and one of your two answers doesn't work. That's called an extraneous answer. Even if you didn't make any mistakes, you got 2 answers, one will work and one won't. So go back and check your answers when it really matters. I get how on homework you want to try to get done quickly. You might not take the time to check them, but when a test is happening and it's the difference between an A and a B, I'd want to take 2 seconds to check. All right. Next, I'm going to add a slide because this got really messy. Okay, there we go. Write that one down, please. I need to get that square root part alone. You already got it written down? Good. So how am I going to do that? Yes, but I can't square it right off the bat. I have to get it by itself first, and then I'm going to square it. So I have to get this part alone. Same as last time. There's a common theme there. How do I get rid of 4? Divide by 4. Square root of x minus 5 equals 12 divided by 4 is 3. I got it alone. Now I'm ready to square it. So I square this side. And I square this side, and I get x minus 5, because the squared just cancels the square root, they're gone, equals 3 to the second, which is 9. I'm really close. What do? Add 5, x equals 14. Now, what should I do? Double check it, make sure it actually works. You go back up, stick in the 14. 14 minus 5 is 9, square root of 9 is 3. 3 times 4 is 12. 12 plus 1 is 13. It works. All right. Wait, I want to add one more page. Drag this one over to that page. All right. Wait a minute, we already did that one. We did that one, but what haven't we done yet? We haven't done that one. Okay. This part, I guarantee you, many of you are going to make a little mistake on your way through it. Okay, and this is what will separate the A students from the B students, or the B's from the C's. All right, if I'm going to start this, yes, I need to get this part alone, just like all the other ones. The grouped part has to get alone first, so everybody do that. Get that part alone. I got it alone. Okay. Now what? You're right that I could split this up into 2, but I don't need to. If I'm trying to get the x alone, I need to get rid of the squared. How do I get rid of a squared? Square root. Get that? All right, so now what do I have? X minus 7 equals 2, and then I add 5, or add 7 to both sides. X equals 9. Go back up and double check it. Does 9 really work? 9 minus 7 is 2. 2 squared is 4. 4 times 3 is 12. 12 plus 7 is 19. Sweet, but you're wrong. If you say the answer is 9, you're wrong. You catch it? Close. It's not, the answer's not plus or minus. So here's the, okay, you are right that there's another answer and it has to do with plus or minus. Let me show you where it should have come in. You know when you do this big square root right here? What should the answer have been? Absolute value of x minus 7. That would give you 2 answers. One of them's 9 and one of them's going to be, like he said, like 4 or negative 4 or something like that. So I'm going to write it out. Split it into 2. Why is this? Because when you take a square root of a variable, see there's a variable underneath here, you got to have an answer that comes out to an absolute value. At some point your teacher should have showed you this, that if you have x squared and you take the square root of x squared, that it will equal absolute value of x. Why? Because think about it. If there's a number like 2 that would work, then negative 2 would also work. You get it? Because when you square it, the negative is like it's not even there. Okay, so it needs 2 answers in a problem like this. Anytime you do a square root, you should slap absolute values on your answer. Okay, so back to here. When I, oops, where'd it go? There. I need to have 2 answers. I need to have x minus 7 equals 2 and x minus 7 equals negative 2. And then I add 7 to both sides, x equals 9. That was a right answer. But there's another one. X equals 5. I'm going to double check that 5 now and see if it really works in here. 5 minus 7 gives me what? Negative 2 squared is 4. And see, it's going to give me 4 either way. There was 2 things that would give me 4. 2 or negative 2 would give me 4, which is what you were talking about. All right, and then 3 times 4 is 12. 12 plus 7 is 19. Okay, so 5 works and so does 9. There's 2 answers. And that's going to separate the A's from the B's on this kind of a test, because you kids that don't remember something like that. All right? So now, when you see a problem like this, this is particularly awful because it's got both. It's got a square to get rid of, and it's got a square root to get rid of. Let me just show you how almost everything that you've learned comes into play on this. First thing is, you could square everything, but the icky part is when you squared this side and you squared this side, then you'd end up with something really complicated over here. It wouldn't just be x to the 4th minus 2. It would be, you'd have to square it out by saying x squared minus 1 times x squared minus 1. Okay? Or you could do the square root of both sides to get rid of that square root. But in that case, we'd have to get the square root alone. So I'm going to start with that. I'm going to divide by 3 and show you how to do it that way. Square root of x plus 4 equals x squared minus 1 over 3. Then I got to square both sides to get rid of this square root. Square this side, square that side. This is the absolute value of x plus 4. You just learned that a second ago. When you have this square roots. No, wait, I'm wrong. That's not the absolute value. It's only if you do a square root. I didn't do a square root. I squared it. There's a difference. If I did a square root, then you do the absolute values. Even I forget. If sometimes I think of squaring, I have to do absolute values. I don't. If I do a square root, then I do absolute values. Okay, anyway. I have x plus 4 equals x squared minus 1 over 3 times x squared minus 1 over 3. And now I have to do, whew, man, this is a pain in the butt. X squared times x squared, this is FOIL. First, outside, inside, last. So it's going to be x to the 4th minus 2x squared plus 1 all over 3 times 3 is 9. Next thing we taught you is how to clear fractions. How do I get that 9 out of there? Multiply everything by 9. Everything by 9. So it's 9x plus 9 times 4 is 36 equals, the 9 would cancel here. So I'd have x to the 4th minus 2x squared plus 1. And now I'd have to get everything over to one side. I'm going to bring this stuff over to that other side. I'm going to say 0 equals x to the 4th minus 2x squared minus 9x plus 36. Oh, this is brutal. Then, yes. You're right. Sorry. This is a negative 36 here. So I go negative 36, so sorry. Negative 35. Is that right? You're right. I screwed that up. Okay. And now, the way to make this equal to 0 would be maybe to factor both sides. And you'd have to do that divide and conquer kind of factoring. Man, there's just so many steps. You see why it would have been nice to graph it? We won't give you anything that nasty on a test. Nothing that bad. Okay? What I would give you, what you would see, something like this. Something like that. Try that one. I'd leave it as 25/3. Then I'd square both sides. 25 squared, I think it's 625 or 9. Then I'd add 4 to both sides. It's ugly, but it's right. Okay. Now beware the extraneous answer. Remember, you go through the whole problem, and it really happens a lot that you get an answer that comes out that won't work. Say I had this, and I do all my steps right, and I end up coming out with an answer of like x equals -2. And it seems like it should work, because you got -2 in here, plus 1 makes -1, square root of -1 is like 1, and then, actually, let's just make it work. All right, this is the kind of thing you'd have. And it seems like it's almost working, but what's the problem? Yeah, you have a square root of a negative. That's an instant, can't do that. It's an extraneous answer. An extraneous answer is an answer that seems like it was going to work, but it doesn't work. When you actually put it in, it doesn't work, because it breaks one of the rules, like you can't have negatives on the square root. Okay? I played poker with a guy who had an extraneous finger. He had the 6th finger. It's actually fairly common to have a 6th finger at birth, and he had one. And usually they don't work. They don't actually function. But it was just kind of like dangling from his hand. And just as like people, he'd like flick it, like bing, 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 flick it back and forth, and flick his like extra finger, and it would just mess with your head. He's got his hands out over the poker table going bang, 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 bang. Stop that. Anyway, and it was an extraneous finger. It looked like a finger, but it didn't actually work. Well, these look like solutions, but they don't actually work. And a lot of people are actually born with that extra finger, but I think he was born in a country where they don't, like, as standard procedure, remove the extra finger, because that's what we do in the United States. If you're born with the extra finger, they're just going to take it off right then and there, and they sew your hand up. So if you have a little scar right here, that means that you used to have an extra finger. I've never had a kid actually find a, like, oh my gosh. But if you have a little scar right here, I think it's like 1 out of every 10,000 people has had that. So anyway, anyway. So that's extraneous. And then the other thing is to watch out for forgetting that thing about when you have like this. If you take a square root of both sides, like this is squared, and then I would say equals, let's make something that works. Let's say it was 9 minus 3 would be 6 squared, which would be 36. So, okay. So it's like that. Do you see how easy it would be to make this mistake? You go, okay, square root, x minus 3 equals 6, x equals 9. And it's sort of right. But what did I forget? Absolute value. It's really the absolute value, so x equals 9 is one of the answers. X minus 3 equals 6, and x minus 3 equals negative 6. You got to split it up into both. And this one's still going to be 9. This one's going to be negative 9. And negative... Oh, dang, if I try to skip a step, I really should go like this. Honestly, I know I just plain screwed up, but I'm trying to show you that I screw up so much more when I don't show my work. Honestly, I'm not doing that. I just screwed up, but it is true that if I try to skip a step and just go bing, 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 even though I'm a math teacher, even though I do this like all day long, I still screw things up like that. And you will too. So honestly, if you take the extra time, I really doubt I would have written that and then said the answer was 9. You know what I mean? Yes. Good question. Okay. So let's say that one of these two answers was actually extraneous. All right. Double checking, I stick in the 9 and it turns out that, oh my gosh, it doesn't work. Then next to this answer, you go like this. Extraneous. EXT is good enough abbreviation. I don't even know how to spell it for sure. I could look it up, but all right. So just say EXT and cross it out. Now, if you said that right from the beginning, that's not good because you need to prove to me what the answer was and that that answer doesn't work. So it'd be fine to get that answer and then say extraneous. All right. The only exception to that would be this. Then you don't even have to proceed with the problem. Why can I just be done immediately? Yes. Can't get a negative out of an absolute value. So right off the bat, you cannot ever have something come out of absolute values and be negative. So I can just say extraneous, or any answer that you would get would be extraneous. All right? You'd think like, well, I'm just going to split it into 2 parts and blah, 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 but it's not going to work. Okay, so you can just say extraneous right off the bat on that one. All right, and there is one like that on your homework, so I'm glad you brought that up. All right. Yes, sir. You mean like 2 seems like it should work, you mean, or what?
No, like a negative 2.
Oh, okay. Let's say you want this to be negative 2. All right, so let's just see if we can figure out some way to make it work. If I just follow the rules and split it, x minus 3 equals negative 2 and x minus 3 equals positive 2, you do one of these as positive, one of these as negative, and then I get x equals 1. I should make sure I don't screw this up now. Okay, and then add 3, and x equals 5. The problem is, even though that both of these seem like I did everything right, when I actually stick in a 5, do you see how it doesn't come out to negative 2? And when I stick in the 1, it seems like it should work, but then it doesn't come out to negative 2. So again, extraneous answers. All right, so watch out for the answer that doesn't work. And also watch out for when you take a square root. If you ever square root both sides of an equation, you've got to remember to do absolute values. Okay, and that'll keep you from losing an answer. All right, then 2 seconds of review here. If you ever encounter fractions in fractions, and you will this year quite a few times, which is why I keep bringing this up. Do you remember how to fix this really quick? You change it into a times. What? You change this to times by 7/5, and that would be way easier problem, right? Okay, but the calc teacher's method also would work. I could times by what on top and bottom? Yep, the common denominator of that. If I times by 21 on top and bottom, 3 goes in here once, 7 times, 7 over, 7 goes in here once, 7 goes in here 3 times, 15. It works fast, and if you understand that, it'll lead to bigger ones like that have a lot of algebra in them, and things will cancel better. So the calc teacher's method is there because there's some real good use for it later. Where flipping over these giant fractions with all this canceling in them would be really cumbersome. But multiplying through by the common denominator would be smart. And the last other thing is, I was dismayed at how many kids had this problem and they did not recognize that it's just a quadratic. And if it's a quadratic, that means you can solve it by 1, graph it. There's nothing on this worksheet that says that you can't. Oh, wait, actually, it does say algebraically. So you wouldn't be able to graph it. Because if the directions say use algebra, you can't graph it. But if I wanted to graph it, just don't forget that way. Y equals this, y equals that. It's really slick. It works on the SAT, ACT. All right. And if you wanted to, couldn't you get everything onto one side and then factor it? That's a very great way to solve these things. That's the second way, is factor it. And if that doesn't work, when all else fails, what always solves quadratics? The quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. There you go. Okay? If nothing else, you could use that to solve this. Don't forget about quadratics. All right? All right. So now, I got your homework for you. It's a nice, simple little worksheet. After those tough word problems you had the other day, this will feel like a fresh breeze. And I am going to take those scores from you. And if you have any homework to turn in, remember you turn it in the last 10 minutes of class. You don't try to hand it in to me. We look at it together. I put it directly in the grade book in the last 10 minutes of class. Anytime you have late work or something. I'll be asking for the scores on the homework verbally in just a second. Remember, you can always opt out of that by saying, I'll tell you later, if you don't want to say it in front of everybody.